Now that you have a pretty good understanding of the basic concepts behind object-oriented programming, it's time to start learning how to apply those concepts in a little bit more of an elegant fashion. Not necessarily complicated, but just a little bit more elegant. So the first thing that we want to do is start to talk about what exactly the solid design principles are before we start digging into any sort of type of application or refactoring or getting into each one of them individually. We're going to talk about what solid is and what all the different aspects stand for. So if you didn't know already, solid is an acronym. So we're going to start by taking a look at SOLID. So the first one is solid, which stands for the single responsibility principle. And all the single responsibility principle stands for is that each class within your application should have only a single responsibility. It should only be in charge of doing a single thing. Now, if you really start to think about that literally, that can sound a little limiting. So really, the way you should be looking at the single responsibility principle is that if you ever had to go in and change a class, you should only have to make a change to it for a single reason. So that single responsibility should be defined somewhere within the requirements or whatever pushed you to creating a class for that reason, and it should be in charge of that one reason, and it should only have to change for one purpose, and that is to accommodate whatever that requirement is. So we'll get into see examples of that a little later on. The O stands for the open-closed principle, and the open-closed principle really just means that your class should be open to extension, which means I should be able to extend the functionality of it, but closed to modification. And what you're going to find as we go through most of these principles is that if you really start to put them all together, they really mean that you should only ever write these classes for a single purpose, and you should never have to change them. So once you write them the first time, they should never actually change. Now they can be extended, and an extension of your class is a little bit different than a modification in that a modification assumes that you're changing the functionality, whereas an extension merely means that you're extending what it can do. You're leaving it open to be able to support any sort of extension of other classes or objects that it needs to deal with. Now, L is a little bit more confusing, and it actually stands for the Liskov substitution principle. And now this one has to do with the concept of inheritance that we talked about before, which basically means that if I have a class B that inherits from or is a subclass of class A, that anywhere in my application that I use that class A, I should be able to substitute into it that class B, and everything should continue to work. So I know that just explaining that verbally might seem a little bit confusing, but really when you start to look at it in an example form, it'll really start to make a little bit more sense. The I stands for interface segregation principle, which really means that many smaller client-specific interfaces are better than larger ones, which if you really start to think about it makes sense, because if I have an interface that I define that has 5 different methods or several different methods and several different properties defined within it, and then I require a class somewhere to implement all 5 of those, but if that particular class doesn't need to use all 5 of those, then odds are I should probably break that interface up into several smaller interfaces so that that class is not concerned about implementing things that it doesn't need. And then finally, the D stands for dependency inversion principle, which simply means that throughout the implementation of my application, I should really only ever depend on the implementation of interfaces and not necessarily the concrete implementations of those interfaces. So one way to use this principle is through something called dependency injection. That's not the only way, but it's definitely one of the more common ways. As you can see here, we have 5 principles that stand for solid, and really over the next several lessons, or for actually the remainder of this course, I'm going to be taking you through an example application that is breaking all of these principles in one form or another, and I'm going to take you through the process of identifying those issues and then doing the refactorings on that class or those classes within the application to start to break things apart and better follow these 5 principles so that we are ultimately creating an application that's much easier to maintain as well as test and ultimately enhance when the time comes.